Welcome to Learning Space Africa. Today we are going to talk about significant figures. In any form of measurement, we encounter significant figures. Take, for example, this 1993 WASSCE November Paper 1 question in the objectives. They are asking us to express 75,882 to three significant figures, and we have four answer options to choose from. Before we can answer this question, we need to learn about some of the rules involving significant figures. One of the rules says that all non-zero digits are significant. So take, for example, if we have the number 1, 2, 3, 7, all these numbers here are non-zeros. Therefore, we have a total of four significant figures. In another rule, captive zeros are significant. What do we mean by a captive zero? Take, for example, the number 3087. In this number, this zero is trapped between two non-zero digits. Therefore, this zero is considered captive, and as a result, it is significant. So in this particular number, we also have a total of four significant figures. The next rule involving significant figures says that leading zeros before a decimal point are not significant. What do we mean by this? So take the number 0.008020, for example. In this particular number, these zeros here are before a non-zero digit, the 8 over here. Therefore, these zeros here are considered leading zeros, and as a result, they should not be counted as significant. However, we do have a zero here, which we learned in the previous rule that this is considered a captive zero. And then we also have another zero over here, right? And this zero is what we consider trailing. Therefore, in this number, we have a total of four significant figures. Now let's pause for a second and think about this. What about trailing zeros that are not after a decimal point? What do we mean by this? So let's take a number such as 3200. In this particular number, we do not have any decimal points, but we do have some trailing zeros over here. What do you think? To make our lives easier, one thing we can do is take advantage of rewriting this number in terms of scientific notation. And if you don't know how to do scientific notation, please watch our videos that we've made on scientific notation. So for this number, we can rewrite it in a number of ways. We can rewrite this number as 3.2 times 10 to the third power, or we can write this number as 3.20 times 10 to the third power. Once we write it this way, when we have scientific notation, we basically ignore the times 10 to the power. We do not count this part here in terms of trying to decipher how many significant figures that we have. So in this particular number, clearly here, these are non-zero digits. So we'll say that we have two significant figures in this number. Even if I look on this option 2, so we said we do not count the times 10 to the power. So here, if we consider this 3.20, we see that we have a trailing zero after a decimal point. And because that is significant, in this number here, we are going to have three significant figures, right? So when we are trying to answer a question like this, it is best that we rewrite any number that we're given that doesn't contain a decimal in scientific notation, and that will help us narrow down our answer options because it presents an ambiguous scenario. So writing it in scientific notation will help us be able to answer the question. Now let's go back to our WASSCE question. So based on the rules that we've learned, we see that this number here, given in the problem, contains non-zero digits. And because it contains non-zero digits, it means that everything here has to be a significant number. So here in the question, they want us to round it down to just three significant figures. So if I have 75882, I need to rewrite this whereby I basically have three numbers. And here we have to use another thing that we have in one of our videos called rounding down numbers. So here, my first three significant figures is the 7, the 5, and then the 8. But right after the 8, I have a digit that is greater than 5. So I have to round this 8 to 9. And once I do that, these two digits here become zeros, right? Therefore, I'm going to have 75,900 as to be to contain three significant figures. And how can we clearly see this? If I rewrite this number in scientific notation, I see that I have 7.59 times 10 to the fourth power. And this is clearly three significant figures. Therefore, when I go to the answer options, I see that C here will be my correct answer. Now pause the video and try to answer this 1996 WASSCE NOVDEC question in paper 1 of the objectives. If you've done this properly, you'll see that in the number 1.02616, all of these digits are significant because this zero is captive, and we learned that captive zeros are significant. But in the question, they want us to round it down to write this number correct to three significant figures. So basically, I'm going to have to consider these here. But before we leave with this, we need to consider this 6 here. This 6 is greater than 5. Therefore, I have to round this 2 here to 3. So I end up with 1.03 as the correct number of significant figures for this particular problem. So it appears that A will be our correct answer. Now let's do one more problem. If you take a look at this number, we're given 0.0030071, and they want us to round this down to write this number to three significant figures. Remember what we said. What do we call these zeros? These are leading zeros, and we said that leading zeros are not, so leading zeros here are not significant, right? So we can go ahead and ignore these zeros over here. So we come down to this part. So we have 3, and then these 2 zeros here are what we consider captive, and we learned that captive zeros are significant. So that would give us 3 significant figures here, but this digit 7 is greater than 5, so we have to round the 0 to 1. So we can rewrite this number as 0.00301. Therefore, in this particular case, it appears that option B has to be our correct answer.